Hello everyone, welcome back to our channel. We are from Sri Vishnu Engineering College for Women and today we will explain some topics in operating system. This video is presented by A. Prasanna, B. Kusma Sirisha under the guidance of Dr. M. Prasad, PhD, Associate Professor, Department of CSC, SPEC, Bhimavaram. Is disk scheduling and selection of disk scheduling. Disk scheduling. It is a technique used in computer operating systems to determine the order in which read and write requests to a hard disk drive or solid state drive are serviced. Disk scheduling is also known as input output scheduling. It is important because it can significantly impact the performance and efficiency of the storage system. Runtime input-output requests for disk tracks come from the process. OS has to choose an order to serve the requests. In this picture, we have to see a process A reads tracks 2, a process B reads tracks 3, 5. A process C reads tracks 8, 4. So OS has to read these tracks 2, 3, 4, 5, 8. Disk scheduling is important because multiple input-output requests may arrive by different processes and only one input-output request can be served at a time by the disk controller. Important terms related to disk scheduling. Disk access time. There is a formula for disk access time. So here we can see disk access time is equal to seek time plus rotational latency plus transfer time. The sum of seek time, rotational latency and transfer is called disk access time. So we have to see seek time. What is meant by seek time? Seek time is the time taken to locate the disk arm to a specified track where the data is to be read or written. So the disk scheduling algorithm that gives a minimum average seek time is better. Rotational latency. What is meant by rotational latency? Rotational latency is the time taken by the desired sector of the disk to rotate into a position so that it can access the read or write heads. So the disk scheduling algorithm that gives minimum rotational latency is better. Next, transfer time. Transfer time is the time to transfer the data. It depends on the rotating speed of the disk and the number of bytes to be transferred. Disk response time. Response time is the average time spent by a request waiting to perform its on input output operation. The average response time is the response time of all requests. Variance response time is the measure of how individual requests are serviced with respect to average response time. So the disk scheduling algorithm that gives minimum variance response time is better. The order that the read or write head is moved to satisfy several input output requests determines the total seek time. It affects performance. The OS cannot change the rotational delay or transfer time, but it can try to find a good order that spends less time in seek time. If requests are selected randomly, we will get the worst possible performance. The main goal of disk scheduling is to minimize seek time, which is the time it takes for the read or write heads of the disk to move to the desired track or cylinder and start reading or writing data. Reducing seek time can improve the overall system's throughput and responsiveness. And disk scheduling having pros and cons. First, pros. It improved disk throughput, it reduced disk head movement and fair resource allocation. And its cons are complexity, inefficient for solid state drives, SSDs, overhead. Scheduling algorithm. The disk scheduling algorithms are as follows. They are FCFS, SSTF, SCAN, C scan, C look. FCFS. What is meant by FCFS? First come, first serve. We know that. It is the simplest of all disk scheduling algorithms. In FCFS, the requests are addressed in the order they arrive in the disk queue. Illustration shows total head movement of 640 cylinders. Here the picture shows their queues 98, 183, 37, 122, 14, 124, 65 and 67, and the head starts at 53. So the first head starts at 53 and then it moves to the 98 and then it moves to the 124. One, because the queue is like that. Next, FCFS having advantages and disadvantages. First, advantages. Every request gets a fair chance, no indefinite postponement. And disadvantages are does not try to optimize seek time, may not provide the best possible service. And next topic is SSTF. Shortest seek time first selects the request within the minimum seek time from the current head position. SSTF scheduling is a form of SJF scheduling, may cause starvation of some requests. So, illustrate shows total head movement of 236 cylinders for SSTF. Here queues are 98, 183, 37, 122, 14, 124, 65 and 67. So head starts at 53. By choosing the SSTF algorithm, first it starts at 53 and then it moves to the nearest path, that is 65, and then it goes to the 67. Like that it reaches at 199. Scan. The disk arm starts at one end of the disk and moves towards the other end, servicing requests until it gets to the other end of the disk, where the head movement is reversed and servicing continues. Scan algorithm, sometimes called the elevator algorithm. Illustration shows total head movement of 208 cylinders. But note that if requests are uniformly dense, largest density at other end of disk and those wait the longest. Scan. The diagram is shown as Q values are 98, 183, 37, 122, 114, 124, 65, 67. Head starts at 53. Now, by using this scan algorithm, head starts at 53 and then it goes to the nearest value, that is 37 and the 14 and 0. Whenever it comes to the lowest value, that is 0, then it moves to the forward and it reaches to the 199, the highest value. C-scan. It provides a uniform wait time than scan. The head moves from one end of the disk to the other, servicing requests as it goes. When it reaches the other end, however, it immediately returns to the beginning of the disk without servicing any requests on the return trip. It treats the cylinders as a circular list that wraps around from the last cylinder to the first one. What are the total number of cylinders are there? The Q values are 98, 183, 37, 122, 14, 124, 65, 67, and head starts at 53. Obviously head starts at 53 only, then it moves to 65, 67, and it meets at 37, and finally it reaches at 37 by using this C scan algorithm. C-look. Look, a version of scan. C-look, a version of C-scan. Arm only goes as far as the last request in each direction, then reverses direction immediately without first going all the way to the end of the disk. What are the total number of cylinders in this diagram? The Q values are 98, 183, 37, 122, 14, 120, 65, 67 respectively. So the head starts at 53. Then we have to see this diagram. Head starts at 53. Then it goes to the nearest value, that is 65 and 67. Whenever it reaches the high value, then only it comes back. So this is a C-look algorithm. Next. Selecting a disk scheduling algorithm. SSTF is common and has a natural appeal. Scan and C-scan perform better for systems that place a heavy load on the disk. Less starvation. Performance depends on the number and types of requests. Requests for disk service can be influenced by the file allocation method and metadata layout. The disk scheduling algorithm should be written as a separate module of the operating system, allowing it to be replaced with a different algorithm if necessary. Either SSTF or Look is a reasonable choice for the default algorithm. And there are some other points which is useful for selecting a disk scheduling algorithm. And why disk scheduling algorithm is needed? Disk scheduling algorithms are needed because a process can make multiple input output requests and multiple processes run at the same time. The requests made by a process may be located at different sectors on different tracks. Due to this, the seek time may increase more. And the disk scheduling algorithm in OS is used to manage input and output requests to the disk. Disk scheduling is important as multiple requests are coming to the disk. Simultaneously, it is also known as a request scheduling algorithm. Various types of scheduling algorithms are there. As we already know that FCFS, scan, cscan, look, clook, etc. And which disk scheduling algorithm is best? So the performance of the look disk scheduling algorithm is better than SSTF. It reduces total seek time as compared to the look disk scheduling algorithm. Look disk scheduling algorithm is increased total seek time. This algorithm provides high variance average response time and waiting time. Look disk scheduling algorithm can handle requests more effectively than SSTF. SSTF scheduling has higher throughput and lower response time than FCFS policy. The main advantages of this scheduling is that is only perform sweeps large enough to service all requests. The main characteristics of good scheduling algorithm is response time, turnaround time, waiting time, fairness, utilization of CPU. This algorithm keeps the CPU busy by using most of it. Throughput. The process involves the number of works finished in a time unit and algorithm increases the number. So, thank, thank you for watching the video.